as close to 98.6 as possible. But do you know why? What is the major reason that we need to maintain that internal body temperature at 98.6?
Because if our body temperature was to go up, it could affect our organs and such, and if it was to decrease, it could obviously affect our internal organs and such.
Yes, but there's a major reason. Well, overheating, I mean, it's not good. You know, the body would need to cool back down, okay? We have to make sure that the proteins of our body maintain their function. A major contributor to proteins functioning correctly is body temperature. If the body temperature goes too high, proteins can denature. Do you guys remember that from general bio? And if you denature the protein, it no longer can function. If the body temperature goes too low, it can affect the effectiveness of that protein, meaning it can't work. Either one of these is and can be deadly to the body. That is not the only thing we have to keep at homeostasis. You're going to learn from this course, hopefully, something that we have to absolutely, positively, without a question, need to maintain: electrolytes. Electrolytes. The salts. It is going to become so important to maintain this internal environment. It's way more than just body temperature. It's hormones. It's electrolytes. It's going to be gas levels, oxygen, CO2. The body's doing way more than just simple little things. The feedback systems, negative, positive. Best example, class first started at 8 o'clock. How many of y'all were hot in here? Was it hot? No? Oh, everybody I've talked to is like, oh, it's so hot there. It was hot. Feels like some air has come on now. How do we normally control this hot and cold in our external environment? Thermostat. Because there's usually something on the wall somewhere that we can go, move a little lever, push a little button, and make this external environment hotter or colder. That, of course, affects our internal environment. That type of control was called negative. Now, in the case of the human, in general, let's think in life in general, we hear the term negative. Does that make us think of something good? No. Okay? We hear negative and we're thinking, okay, well, that's negative. All right? for our body, the way that we're going to maintain homeostasis is called negative feedback. For the most part, we maintain homeostasis with negative feedback. Meaning, something happens, the body tries to bring it back to normal. Stop it, and let's bring it back to normal. We do have some positive feedback systems in the body. For the most part, they are detrimental and can lead to death. Okay? But there is a type of positive feedback our body has that is actually beneficial, and it's called childbirth. When you have positive feedback, it continues to feed the system. It doesn't try to stop it. Now, for our purposes, as we continue in this course, negative feedback is going to be the one we hear the most. Feedback systems they have parts, just like the parts of a motor, okay? We have to have a receptor, something that receives information. We have to have a control center, something that integrates and makes sense of the information. And then we have to have an effector, something that carries out what the control center said to do. The best example that I can give you for today. When we got here at 8 o'clock and it was hot, this was my external system, but it was affecting me internally. Do you happen to know if we have receptors for that heat that I was feeling? Do you know where they're located? In my skin, okay? So, in my skin, I have something called thermoreceptors. Thermo for heat, okay? It's a nerve ending. That nerve ending picked up that it was hot, sends information to my control center. Do you know where the control center was? Or where it might be?
Your brain?
My brain. I'm going to have a center in my brain that's monitoring my body temperature and picking up all this information, and it picked up that I was a little too hot. Now, it had to integrate that information, it had to make sense of that information, and it had to give me an effect. It had to make something happen. Can anyone tell me what it made happen for me? I started sweating. Which means that that heat that was being carried in my blood, okay, if we think about that vascular system, because it was hot now, it brought it to the area of capillaries under my skin, made them open and let the heat out. And I started sweating. So I had a receptor, I had a control center, and I had an effect. I had a stimulus because the stimulus was the external environment and it was hot. And my response, I sweated. That's probably the best example I can give you right now. But it doesn't mean that as we move along in the course, there are not going to be tons more of these. So homeostasis, maintaining that internal environment, and determining what it's going to do with it, how it's going to maintain it. So before you leave for today, I need for you to make sure that your assigned lab safety is left just right here on the desk. The form that you had for the syllabus scavenger hunt, I want you to take just about 1 to 2 minutes. I want you to flip it over and on the back. I want you to tell me 2 things that you learned today. And if you have a question, put your question on that paper. And you can leave that with your lab safety agreement, and I will see you on Wednesday.